In this video, we're going to take a close look at cumulative frequency curves. So what is a cumulative frequency curve? Cumulative frequency is the running total of frequencies in a frequency distribution. A cumulative frequency graph or cumulative frequency diagrams are useful when representing or analyzing the distribution of large grouped datasets. They can also be used to find estimates for the median value, the lower quartile, and the upper quartile for the dataset. The horizontal axis of a cumulative frequencies graph is marked with the class intervals for the dataset to be plotted on a continuous scale. Data points are plotted on the upper class boundary. The vertical axis of a cumulative frequency graph is always labeled cumulative frequency. In order to draw a cumulative frequency graph, there are 5 distinct stages. First, you need to calculate the cumulative frequency values for the table of data. Here we have a frequency table. It's to do with how long it takes somebody to do a puzzle. So we've got the time in minutes, going from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and then we have the frequencies 20, 24, 30, 12, 8, and 6. And the cumulative frequencies are done in a separate column. So here we are. The first one will be 20. The second one is 20 plus 24, which is equal to 44. The third column is 44 plus 30, which is equal to 74. The next row is 74 plus 12, which is equal to 86. The next is 86 plus 8, which is equal to 94. And the next is 94 plus 6, which is equal to 100. So altogether, 100 people were timed on how long it took them to do this puzzle. The next thing you have to do is draw yourself a set of axes with suitable labels. So it's already been drawn. We've got time along the x-axis, cumulative frequency along the y-axis. We've got a suitable scale going from 0 up to 60 for the time and going from 0 up to 100 for the cumulative frequency. The next thing you've got to do is plot each value at the end of the interval. So for each grouped data set, you plot the last or upper boundary point. So we'll plot 10 against the 20, the cumulative frequency. We'll plot 20 against 44, 30 and 74, 40 and 86, 50 and 94, 60 and 100. Once you have plotted the points, you join the points with a smooth curved line. So I've joined in the nice smooth curve. I always find it's easier to draw it from the top down to the bottom, going below the data points. And the final thing you need to do is, like with any other graph, is to make sure you add a title to the cumulative frequency curve. So in this case, it's the time to complete a puzzle. As we said earlier, the cumulative frequency curve can be used to find an estimate for the mean. And in order to do this, the mean occurs at 50% of the data. Well, it's nice and easy here. We've got a cumulative frequency of 100. So to find the mean, we would go to the cumulative frequency 50, draw a line to the graph, and then down to the time. So I've done that, and we can say that the median is equal to a time of 21 minutes. We can also use the graph to find the lower quartile and the upper quartile. The upper quartile is at 75% and the lower quartile is at 25%. So I've drawn those two lines in and I get Q1, the lower quartile, to equal 13, and I get the upper quartile, Q3, to equal 29. I now have my 5-point summary that I could actually, just below the cumulative frequency curve, draw a box plot. And there is my box. There is my median, and I can draw the whiskers in up to the maximum and the minimum, and I can see from the box plot that it's slightly skewed positively. Let's go through the typical exam style questions you might come across. So question 1. The weekly wages in dollars of 80 employees are displayed in the cumulative frequency curve below. Part 1, write down the median weekly wage. Part 2, find the interquartile range. Well, for both of these questions, we're going to need to use the graph. So for the first bit, write down the median weekly wage. Well, the median weekly wage, seeing as there's 80 employees, we want to find the 40th employee. So we want this employee here. So we're going to draw a line from here along to the graph and then down to the weekly wage. I've drawn on my line for the median, and I get my median wage, or Q2, to equal $395. Remember, it's only an approximation. In part 2, find the interquartile range. So for the interquartile range, I need to know Q1 and Q3, and again, I get those from the graph. Q1 is 1/4, which is 20. Q3 is at 3/4, which is 60. So I'm again going to draw lines horizontally to the graph and then vertically down to the wages. Having drawn the relevant lines, I get Q1 to be $325, and I get Q3 to equal $465. And I know that my interquartile range is equal to Q3 minus Q1, which is equal to 465 minus 325, which equals $140. Question 2. In some instances, you might be given a cumulative frequency curve and asked to work backwards to fill out a frequency table. In this question, the following cumulative frequency curve shows the amount of water in litres that 60 people drank over a month. A. State whether the data is discrete or continuous. Well, because it has to be measured, it's water, it's in litres, the data is definitely continuous. Part B. Complete the following frequency table. So we're given a frequency table with the groups already given. We're asked to find the frequency and the cumulative frequency. Well, we can work backwards from the graph. We can find the cumulative frequencies, and remember, it is always the upper bound and the cumulative frequency that are plotted. So we can look for the cumulative frequency at 30, so 30 and read it off, 50 and read it off, 70 and read it off, 90 and read it off. So looking at the graph, the cumulative frequencies are 60, 50, 28 and 10. So that means the frequencies must be 10. Well, 10 plus 18 gives me 28. 28 plus 22 gives me 50. And 50 plus 10 gives me 60. Now I have completed my frequency table. Here's a little summary about cumulative frequency curves. When drawing it, remember it is always the upper bound against the cumulative frequency in every case. So the upper bound against the cumulative frequency. A cumulative frequency curve should be a nice, smooth curve going through all data points, and it can be used to find an estimate for the lower quartile, which is at 25% of the data. So in this case, seeing as the cumulative frequency maximum is 10, that's at 2.5. An estimate for the median at 50% of the data, in this case at cumulative frequency 5. The upper quartile at 75% of the data, in this case at cumulative frequency 7.5, and it can also be used to find the cumulative frequency for any percentile, as long as it is calculated against the cumulative frequency. Remember, cumulative frequency always goes on the y-axis. The name of your data always goes along the x-axis, and remember it is for cumulative data. And remember that all graphs, whether cumulative frequency curves or any other graph, should have a title. In this case, number of minutes of exercise by a sample of people.